All right, and welcome to the final video for Chapter 5. We're looking at what's going on in the brain whenever we are paying attention. And this is kind of a difficult area to talk about because there is so much going on in the brain whenever we are paying attention that there's not specifically one area. And that's why this is difficult, is because attention is not localized. In other words, there's not one part of the brain that is the attention area, that instead it is distributed throughout the brain. It is a very wide network that is very complex, and it really depends on what you're paying attention to. That is going to change what areas of the brain are active whenever we are paying attention to something. So the primary suspects that we're going to see over and over and over again, however, are going to be the superior colliculus, the posterior parietal lobe, the pulvinar, which is a part of the midbrain, and sometimes the anterior cingulate cortex, the ACC. Those are the areas that most commonly are found whenever we are trying to study attention in the brain, using MRI, using EEG, not really using PET as much, just because PET imaging is very slow, and this requires usually very, very fast tasks to really be able to kind of look at attention. So I'm going to give you, this was probably the last time we'll talk about this specific article, but I like it for a lot of reasons because it illustrates so many different aspects of cognitive psychology. But the O'Craven article that we talked about from Chapter 2, this experiment is where they had people look at images, where they had two things overlaid on one another, and what they essentially found is that if you were asked to look at a face, that the fusiform gyrus would be activated, and if you were looking at the house, then the parahippocampus would be activated. And so even in this case, where you're looking at visual information, the parts of the brain that are responsible for attending to that information is going to be different. So if you're paying attention to the face here, there's a different part of your brain that will be active than if you are looking at the house here. And that's part of the reason why studying attention in the brain is so difficult. So you have to be very, very clear about what the specific kind of stimuli are, and you have to be very careful to control for that to make sure that you don't have something like the fusiform face area active just because you're using faces as your target stimuli. Here is one thing that we do know about attentional mechanisms in the brain. And actually, before I even go into that, the way that I said that kind of came out wrong. When I said one thing that we do know, we know a lot about how attention works. It's just that for an undergraduate class that doesn't have a super deep background in neuroimaging, we're not able to go into a lot of specifics. If we want to, there's a ton of research out there on attention and how it affects the brain and what parts of the brain are active during different kinds of attention, but it's so complicated that it's almost not even worth us really kind of trying to get into here. But instead, what I'm going to talk about are the big picture items. One of those is going to be what's called visual neglect, and visual neglect is usually happens because of a lesion. So thinking back to the language that we use in Chapter 2, a lesion is whenever we have some kind of brain damage. In this case, that is going to be in the parietal lobe. And we know that the parietal lobe is important for attention because we see that whenever the parietal lobe is damaged, that it affects people's ability to pay attention. And generally what this means is that people are able to maybe pay attention to the big broad picture of things, but not really be able to pay attention to the local small features of things. So if you have damage in your left hemisphere in the parietal lobe, you would have trouble attending to these small local features, but the opposite is true if you were to damage the right parietal lobe. You would actually have trouble attending to the global features. So here is a quick way of looking at that. In both of these, in all these experiments, they had these different people that had brain damage or neural lesions come in. And so what you're going to see here in column A is going to be people with bilateral parietal lobe damage, which means that they had some damage in both hemispheres. What you're going to see in column B is going to be someone that has parietal lobe damage in just the left hemisphere. In just the right hemisphere. And then in column C, you're going to find someone who has parietal lobe damage just in the left hemisphere. Okay, so what people were supposed to draw was something like this. It's kind of, I always think of it as kind of like a house or a rocket ship or something like that. But so they're looking at this image and they're drawing it out, right? So they're not doing it from memory. They're just drawing it out, and they can see it in front of them. The people that had parietal lobe damage in their right hemisphere, they didn't get the big picture, right? They only got these small features, but you can tell they got some of those small features, right? But not the big overall shape. But the opposite was true for those that had damage in the left hemisphere. They got the big kind of shape, the big kind of picture, but didn't actually get the small local features. Here's another example. So in this case, this is what you should have drawn. And we see that people with parietal lobe damage in the right hemisphere were able to pay attention to the squares that make up this figure, but didn't really seem to be able to capture or attend to the exact shape that it was, which is a triangle. And the opposite is true for those that had parietal lobe damage in their left hemisphere. There they got the overall picture, but didn't get the actual components that make up that picture. And finally, we see here people were supposed to draw this, the letter M composed of Z's, and we see that people that have parietal lobe damage in the right hemisphere basically just write a bunch of Z's. And then people that have parietal lobe damage in the left hemisphere just draw the M. So we see these differences in our ability to pay attention and what we can focus on depending on where that damage occurs in the brain. Here's another example of unilateral neglect syndrome. So this is where you have damage in the right parietal lobe. That it can be that you have damage either focusing onto the global or local cues, or it could mean that you have trouble kind of attending to specific sides of a space. And so people were looking at a clock and they were supposed to draw out that clock. And you can see that basically they draw everything kind of crammed into the right-hand side and nothing on the left-hand side. They can't pay attention to the left-hand side. The thing that I think is kind of fascinating about this is that it seems like this individual knew that 12 should be up here at the top and that 6 should be down here at the bottom, and it seems like they almost kind of cram things up to get to 9, whenever we kind of know that's not how it should be. The final thing that I want to talk about here is going to be ADHD, because usually in classes people have good questions about ADHD. This is something that you should talk about more in your developmental classes or in abnormal psychology. But basically there are brain differences in people that are experiencing ADHD, or attention deficit hyperactivity disorder. That disorder is hallmarked by usually difficulties in paying attention. And yes, we do find that there are some areas that show differential responding, usually less activation than other people that don't have ADHD. So you can actually look at the different ways in which those problems occur, and you can trace them back to where those areas take place in the brain. And so this is an example of how distributed, how complex attention is, that just something like ADHD, you can see all the ways in which it impacts what's going on in the brain. So if we're looking at problems in your ability to be alert, part of that is your ability to sustain attention, part of that is going to be your ability to finish projects, and part of that is going to be your ability to avoid things that consistently distract you. Those happen in the right frontal cortex, the right posterior parietal, and the locus ceruleus in the midbrain, all over there. If it's problems in your ability to focus on specific things, that could be you're distracted by stimuli, you don't appear to listen, or that you can't pay close attention. All of these are different areas of the brain as well. And you might also have problems with your executive system, so your ability to kind of control your own behaviors. Those three things are all handled by separate systems of the brain too. So someone with ADHD is going to have potentially all of these different areas of the brain are acting a little bit differently than you might expect with somebody that doesn't have ADHD, which is, I guess, helpful in a way that you might be able to put someone in an MRI scanner, scan their brain, and be able to determine whether or not someone has ADHD by looking at these specific kinds of profiles of what you might expect. All right, so I think that's pretty much it that I want to talk about for this specific chapter. We're going to jump into chapter 6 now, talking about memory, and I could not be more excited. I love memory, and I will see you there. Goodbye.